Ladies and gentlemen, Redis geeks and geekettes, welcome to Redis Day.
Hello everybody, my name is Danny. I'm gonna showcase today a module that I worked on. I started the module about a year ago. The module is basically a custom data type in Redis. The data type is time series. So let's first talk about what is a time series. A time series, if you think about it, is basically a sorted list of samples. Each sample is a timestamp and a value. So if you have multiple samples, you have a time series. In the example in the graph, you can see we have 7 samples that together are a single time series. Usually, time series can come from many types of producers. In our industry, normally, we talk about monitoring and IT metrics. It can be CPU, memory, ops per second, or temperature of the server. But in the industry outside of the IT, we have different types of producers. It can be an IT, an IoT device, or some kind of a temperature sensor, for example. When we're talking about time series database, generally, a lot of the time we're also talking about different rolling data. So, for example, if we want to keep data in downsampled fashion, so we can save a lot less data in memory or on disk, normally we call it a downsample. We're gonna talk about this a little bit later. So I started to get into the time series database around a year ago, and I got to know more and more about how time series work and what they're good for. And I start to really like the time series itself. So the time series are really easy to work with. For once, it's almost always a sorted data type. It's sorted by timestamps, and the timestamps are in ascending order. We can assume that timestamps are bigger than the previous timestamps. We can index it a lot easier. For example, Salvatore in the streams data structure use the radix tree to index the timestamps. Timestamps are indexed in a very easily fashion if you compare it to other data types. And today there is also new types of compression algorithms for time series. Facebook showcased their Gorilla document about a year and a half ago, a year ago. They showed a much faster and better compression algorithm for time series. So why store time series in Redis? So this can be a little bit of a funny question. A lot of people already do that. Actually, in Redis Labs, we've been doing that for many years. In our enterprise product, we store our metrics of the cluster inside the cluster using Redis. So normally, when people talk about time series in Redis, they talk about sorted sets. Sorted sets is a nice trick to store time series because you can put the timestamp as the score and then use a ranged query on the sorted set to get the data. But sorted set was not implemented to solve that specific problem. But people still use that. And we use that, and many other people. If you look Google and search for Redis time series, you will probably find more than one document that will tell you to use sorted sets. So sorted set was the main feature for time series until lately. And another thing that happened in the last couple of years that many open source databases for time series started to evolve. And Facebook, as I said before, they published a document called Gorilla. What happened in Facebook is that they got to a point where they got so many metrics from all their production environment that they could not store it in any known database that they had. So they went and they built a database from scratch. The database today is open source. It's called Barangay. And what they did is basically they created a cluster charted in-memory database only for time series. which is kind of funny because if you think about it, Redis is a clustered, sharded database. So if you can leverage Redis for time series, there is a really, really good use case to solve a lot of problems for a lot of people. And of course, Redis is fast. And many people need to showcase their data in a really fast fashion. For example, if you have a product that has dashboards, you probably want your dashboard to show up quickly. If you do dashboards today and you use a traditional SQL server, you will probably notice that it takes time to query the data and aggregate it. So if you can use Redis to make your dashboard even faster, that can be an awesome thing for Redis. And last and not least, Redis server is really easy to deploy. It's really easy to embed. It's basically just one binary. So if you want Redis with time series, you basically can take Redis server and the module, the shared object module, put them together, and you have a really easily embeddable Redis server with time series. So what is the module that I worked on? So I started to work on the module around a year ago, and it was before we had the streams in Redis. And I looked into how to do that. So basically, this is a custom data type in Redis that is needed. It's implemented towards time series specifically. Time series, numeric time series, and not just any time series. Each key that is created as a time series will have its own time series, and the keys are independent from each other. One of the benefits of using the Redis for that is that, as I said before, we can leverage all the Redis infrastructure and all the Redis basic features, which is persistence, sharding, and clustering, and high availability, which is something that many, many, many people need today. And if you look at traditional time series database, it's really hard to do them. It's really hard to shard them, it's really hard to cluster them, and it's really hard to do the highly available deployment of them. Some of them actually make you as a developer, you need to build your own software to make them highly available. Okay, so we're gonna go through and showcase a little bit of what kind of commands I have. So the first command, which is the most important command, is the TS.ADD. Basically, what you do is you add a new sample to the time series. And this sample is basically a timestamp and a value. In this example, we have a temperature, and we have 3 samples. The first sample is ended in 7. And you can see that each sample has a different timestamp, and the difference between the timestamp doesn't have to be the same. So we don't have any type of heartbeat or anything that makes sure that it comes in the same sample rate. So you can sample it at any rate you want. And the value can be at any value that you want, as long as that it fits into a 64-bit double. One caveat that is important to mention is that you cannot add timestamps that are older than the maximum timestamp that you already have inside of the key. A new command I added lately is the TS.INCRBY or TS.DECRBY. The use case for the INCRBY and DECRBY is something that sprung to me in the last weeks. A lot of people use Redis today for counting. We saw that actually in the previous presentations. People count stuff in Redis. So normally, if you have a web app or you have a mobile app, you want to count how many active users you have. So what you do is you use a hash map, and then you have buckets. And each bucket will probably be the date, the hour, the minute, or the second. It really depends what kind of buckets do you want. And you will use INCRBY or H.INCRBY, and you will have counting inside Redis. So that is a really, really fast way to do counting. But if you want to have also the history of the counter, it's really hard to do that today in Redis because you need to manage the history by yourself. So if you want to do different types of aggregation on the time, you need to build the buckets by yourself. So here comes the TS.INCRBY and DECRBY. Those are commands that you can use for counting. When you use this command, you basically get the latest counter, but you can also get the history over time of the counter. So if, for example, here we have two commands for the active machine. Let's say we call the active machine in the timestamp 0, and then we call the .DECRBY active machine 1 in timestamp 1. You can see that the latest counter will be 2, but if you look at the history, you will see that there is actually more than one counter, and you can see the trend over time. So this is something that people already do today, but it's done sort of manually by their own code. Of course, you can increment and decrement by any number that you want. It's also important to know that the clock that will be used is the Redis server clock. So if you trust your Redis server clock, that's OK. If not, you need to think about it. The last example is something that I added also lately, the reset command, which basically what it does, you can ask for a counter. There's two types of counters or like names of how you count stuff. Generally, there's gauges and there's counters. The gauges are basically something that it's like a memory. It's something that states a state at a certain time. And a counter is something that you count over time. For example, if you want to count hits, then this is a counter. If you want to get the memory usage, this is normally a gauge. So in the example, the third example, you can see that we are counting the active users, and then we're asking for the reset of the counter. So what it does, that every 5 seconds, the counter will be resetted. So we are counting the number of active users every 5 seconds. OK, so the next command is the query command. It's called TS.RANGE. The TS.RANGE command is basically how you query the data and get the data back to you. So the important thing about the TS.RANGE is not just ranged query. It's also aggregated queries. You can aggregate using average, maximum, minimum, counter, or sum. And you can pick what type of time bucket you want. So if you want to aggregate for 5 seconds, you want to aggregate 10 seconds, or you want to aggregate 1 hour, it's up to you. Every time you query it with the aggregation, you will get the samples truncated by the time bucket that you want. So we have 2 examples here. The first example is just a simple range query, and the second example is an average query of the same time span. The difference is that we want the query to aggregate the data over 5 minutes. So we will get samples that the difference between each sample is 5 minutes. And every sample will have the average of all the data during that 5 minutes, and it will be averaged. OK, so we talked about downsampling before. Downsampling is a mechanism or a technique that's used a lot in time series database. So as I said before, time series databases normally started as something for monitoring. So when we monitor applications, normally we don't really care about the per second resolution. Maybe if your Facebook per second resolution are important, but most applications, they are OK with downsampling the data and keeping the data in a much lower resolution. So what is downsampling? Downsampling is taking the graph. For example, we have a left graph where we have a sample per 10 minutes, but it's not really important to save that resolution. So what we do, we aggregate that data and keep it in much lower resolution. For the right graph shows us the aggregated graph, which are basically the same data. It just averaged over 1 hour. So we keep 10x less data for the same use case. So it's true, we lose data. It's a lossy compression, but we can save a lot more data over time. So you can do that today in the time series module. You can create a downsampling rule, which is basically taking a time series key and saying that every time that this bucket will end, we will downsample the time series to a different key and having the data in a different resolution in a different key. So here you can see we're creating a rule for a temperature with an average of 60 seconds, and we're going to save the downsampled data to a different key that's called temperature_AVG_60. So you can pick whatever you want. If you want average, if you want COM, you need to think about what data you have, because each data has a different type of aggregation that fits to it. Also, it's important to note that there is a performance impact for downsampling, but it's really limited, because what happens, we keep a context in memory of how much data you got, and we aggregate it on the fly, and only when the context of the aggregation is ended, only then we open the destination key and flush the data. In that sense, we do not use a lot of the Redis resources. There is global configuration. You can load a module with different configuration. You can pick the default downsampling policies, and the module will create the keys automatically with those policies that you created. You don't need to manually create the policies for each key. OK, so I talked about the differences. I talked about that people already use sorted sets. So sorted sets are OK for time series, but you don't get a lot of the things that you might get in a more optimized data store. So you don't get range query with aggregation, which in sorted sets is a little bit of a problem. If you use external keys with sorted sets, you will get more traffic between the client and the server, and it will hurt your performance. But also, you don't get any retention periods, and you need to do everything manually. OK, so streams. So a lot of people ask me, so what's the difference between streams and my module? So there is a lot of similarity. There's basically the basic concept is very similar. You have timestamps and you have data per timestamp. What I've been working on is something that is it's a very specialized stream. It's a stream that all the data are numeric. If it's numeric and we know that it's numeric, we can do stuff that you cannot do with just any general time series. For example, you cannot do downsampling for log data or event data because you don't know what is the value itself. You cannot do aggregated queries because you don't know what kind of aggregation you can do if it's a textual event, for example. We do plan in the future to have some kind of integration with the streams. So this might change, but at the moment, we're doing something that is very, very specialized for time series, numeric time series very specifically. For example, the automatic downsampling you cannot have in the default streams in Redis. OK, that's it. I have another minute and a half. You can find the product, the module in my GitHub. And if there is any questions, there is 1 minute to go.
Why can't I add older timestamps?
Sorry, what's the question?
Why can't I add older events?
OK, so I didn't talk about the memory module itself. It's similar to how stream works. So I'm using chunks, and each chunk has a certain amount of samples. So after the chunk is done and is finished, we append more chunks to the end of it. We prefer not to open it and re-add timestamps, because it will be an expensive operation that you will need to open the chunk, re-chunk it, and do a lot of re-indexing.
Thank you very much, Danni.
Thank you. Thank you.